Hey everybody, I am going to attempt to diagnose and service my dryer booster fan. This is a Fantech model dbf110. And this is a dryer booster fan that I installed. And essentially what it does is if you have long runs of dryer duct, it actually goes in line and it automatically comes on when your dryer is on, because it's got what's called a pressure switch, which is this device here. There's more going on in there, but I'll get to that in a minute. Essentially, you get this little tube right here. This is on the side going to the dryer. And when the dryer turns on, enough pressure builds up in this pipe and goes through this little tube, which normally attaches here. I'll get to that in a moment. And it pushes on a diaphragm in here and closes a switch that then starts a chain of events. The first event is that it starts the booster's fan motor spinning. And then there's also a circuit built into this so that when the dryer shuts off and the pressure goes away and the diaphragm moves back and the pressure switch opens, it doesn't just shut the motor off. The motor will continue to run for several minutes, I think about 10 minutes before it shuts off. So if you're just opening the dryer to check the check the clothes or something like that, the fan will continue to run. It doesn't just shut off immediately. So the switch is doing a lot more than just turning this motor on and off. There's more going on here. Okay, so here's the symptoms I have, which is well, first let me back up by saying you have to follow the installation instructions very closely. There are certain rules that they basically want you to abide by in the installation of this unit. They want to have a certain amount of duct length between the dryer and the input here. So you wouldn't want to mount this like right directly on the output of the dryer or shortly after the output of the dryer. I believe part of the reason for that is because the lint coming out at that point could still be very damp and it might have a tendency to want to stick. Also, if you have an extra, I think if you do have to mount it closer, I think you can maybe do that. You have to check with the manufacturer, but I think they're going to require you to install a secondary lint filter. And, that's something that, again, if you can avoid having to deal with the service of another secondary lint filter, try and avoid it. So, anyways, getting back to the problem at hand. I installed this unit about 2 months ago, and initially I couldn't be happier. This thing, we noticed almost immediately a couple of different things. First thing we noticed was the drying time of the clothes actually dropped. So when it would normally take X amount of time for our dryer to dry a certain load of wash, that was cut drastically. I didn't do any calculations to figure out exactly, but I definitely feel that the shorter drying time more than pays for in savings of electricity, the electricity used by the booster fan here. In other words, the booster fan's using electricity the entire time that it's running, which is pretty much the entire time the dryer's running plus about 10 minutes. But keep in mind that now the total dryer run time is decreased, and the dryer heating element is what uses the big electricity in this equation. That is that's a real energy hog. That's why dryers run on 30 amp 220 volt circuits. It's because of that heating element. So if you can minimize the runtime of that heating element, you're going to improve efficiency. So that's the first thing we noticed, was that. And then also, haven't found out yet, but it should help keep the duct cleaner, actually, because it's going to keep the suspended lint moving more quickly through the system and exhausting outside, as opposed to having a tendency to want to get bogged down and stick to the sides of the inside of the vent. Don't get me wrong, you still have to service your dryer duct, you still have to clean it. The manufacturer actually recommends at a minimum of every 6 months that you go look inside this fan to see whether or not it's dirty. I want to make one more comment for those of you who are astute enough to observe all the lint that's on the, we're actually looking at the back side of the blue board for the plaster ceiling below us. That is from an earlier situation where the dryer duct, the joints weren't taped, and the joints were leaking enough small particles of lint that over time it actually collected into this thin little blanket of lint inside there. So anyways, so that was 2 months ago, installed it, and everything was great. Then what I noticed was I happened to be up here in the adjacent room, and we had a load of clothes drying, and it was in the middle of a drying cycle, and I noticed that I kept hearing the fan turning off, and then after, like a few, maybe 10 to 30 seconds, it would turn back on again, and it would run for anywhere from 30 seconds to a few minutes and then shut off. So something was happening erratically. So I thought, well, there is a procedure for actually adjusting this pressure switch. This pressure switch is almost perfectly vertical right now, which is how it's supposed to be oriented. And you can actually remount this pressure switch so that it's tilted a little bit to one side or the other. If you turn it to one direction, it actually decreases the sensitivity. So if the unit's coming on when it's not supposed to, if you put it to the other side, it increases sensitivity, and that would be if it's not coming on when the dryer is coming on. It might be a symptom. That might be a symptom of a problem there. But this was working perfectly fine, and then started doing this weird thing. So that tells me that it's not an adjustment. Why would it change? Unless there was a blockage or something. But again, it hasn't been running that long. And here's the other dead giveaway. What it started doing yesterday was the dead giveaway that we had a hard failure of a component and not actually a problem with installation or with mounting of the switch. It's not an adjustment issue. And the failure that we found yesterday, I happened to come up here while the dryer was running. I hadn't gotten around to attempting to adjust the pressure switch. And what did I hear? Well, I heard it not running, and then running, not running, and then running, and in very, very short intervals. Shutting off so quickly that, in fact, it never even came up to full RPM before it would shut down. So I'm going to demonstrate that now. And since the dryer is downstairs and it's too difficult for me to go, I'm not going to go running downstairs. What I'm going to do is I'm going to simulate. And also, I saw somewhere in a troubleshooting section online that one of the ways you could troubleshoot this pressure switch issue is you could disconnect the line right here. They actually recommend disconnecting it from this end, but this is in this kind of tight grommet here, and I didn't want to force it, didn't want to come out easily, where it comes off of this brass nipple real easily. So what I did was I disconnected it from this end, and I just have a little scrap of extra line that's close to the right size. It will fit on here with a little bit of effort. So ideally, this would be a little bit bigger in diameter. And then what you do, because this pressure switch is so sensitive, it doesn't require a whole lot of pressure to activate it. You just blow into this line and it'll turn it on. So first, let me start by saying, if you decide that you want to service, I'm not advocating anybody service this on their own. And if you decide to take it upon yourself to try and service this unit, first thing I would warn is definitely disconnect the power anytime you're messing with this thing. And like I said, you've been warned, don't do it. So what I'm going to do is I'm going to blow into this little tube. And what you'll hear initially is you'll hear a tiny click, which is the tiny switch inside here that the diaphragm actuates closing. Immediately after that, you'll hear a louder click, which is actually a relay by the sounds of it. I'm not sure how this is actually made, but it sounds like there's a secondary relay. There's probably a circuit in here. So the switch that closes when the diaphragm is actuated must not be a high current switch that actually turns the motor on, because if that was the case, as soon as the diaphragm moved out of position, the motor would shut off. And remember, I said that there's some sort of a feature in here that allows the motor to continue to run for about 10 minutes after this switch is deactivated. So let's do that. So you can hear what happens. Basically, you can hear the tiny switch in here close. And then you hear a loud click. The motor starts to spin up. And then you hear that click again immediately. The motor slows down. And then it just keeps repeating itself. As long as I'm blowing into this tube constantly, it will just keep doing that. So something's really haywire inside this thing. So I called tech support, and the gentleman I spoke to said, well, he said, first he said it seems highly unusual to him, the symptom that I'm having. And then the second thing he said was that it definitely sounds like a bad pressure switch. So the pressure switch is actually this whole assembly right here. It's actually a db110. So db110 is the model number of the pressure switch itself. So that's what I need. So I've disconnected the power to the unit, and I removed these two screws that mount this bracket to the actual housing, and that will allow me to tilt this switch position so that when I take this cover off here, it's going to make my life a lot easier to disconnect the wires, which is what I've got to do next. Now, I could see right here, you see this screw right here that's got some goop on it to keep it from moving? I can almost guarantee you that that is a sensitivity switch right there. So I could see where changing the position of this screw would definitely alter the behavior of the unit. However, I'm not dealing with a sensitivity issue. Remember, I basically, by blowing into that thing with my breath, I'm keeping that diaphragm and that switch closed constantly, and the unit just keeps turning on and off. So if something else has gone wrong here, it's not a sensitivity issue. So I definitely don't want to mess with this. It's also worth noting that these screws also have a dab of goop on them. And that's not there to keep them from falling up from vibration. I can almost guarantee you that's there, so that's basically they'll know whether or not this was tampered with. So as soon as I remove those screws and I break that goop right there, that's going to void any warranty on this unit. So if I were to send this unit back for credit and they saw that that was already tampered with, they would use that they could use that as an excuse to void my warranty. I actually spoke with the technician and explained that because the way this is in here, it's kind of hard to get at. I would really just rather replace the pressure switch and not the whole unit. And he readily agreed that he'd be willing to send me out just the pressure switch instead of the whole unit, and that's fine with me because this unit's only 2 months old. I certainly don't have a concern about the motor being bad. Oh well, yeah, there you go, right there. We got a whole logic board in here. We got semiconductors. We got integrated circuitry, capacitors. All right, so and there's your relay right there. That block right there, that blue block in the lower left-hand corner that says 12 VDC, which 12 volt DC. That's basically a relay that has a 12 volt coil. So when 12 volts is applied to the coil of that relay, it closes its contacts and fires up that motor. So that's our little circuit right there. More than likely something on there is what's haywire, but it would be pretty hard to tell what. Now, interestingly enough, if I were venturing to guess what went wrong with this unit, I would probably want to suspect one of those electrolytic capacitors. Those metal, let me see if I can get this flashlight magnet to work along. There we go. All right, so right over here, guys, we got right here this device and the smaller version of it down here. This paper's kind of in the way right there. Those two devices right there are what are called electrolytic capacitors, and they can be prone to failure in a way where their capacitance value can change and drastically alter the way a circuit acts, or could just completely cause the circuit to fail. So, you know, one of these capacitors could easily be having something to do with the timing circuit, and its value changing could definitely cause it to act kind of crazy. I don't know. But anyways, that's what's going on inside this thing here. So, well, that's dirty pool. I could see the wires go into the PC board and they're soldered in. So in order for me to remove this pressure switch, I have to undo the other end of this cord from the main junction box, which means, well, guess what that means? That means I shouldn't have taken this cover off at all. So I hope I don't have a problem with my warranty. I might have a problem with my warranty anyways, because he asked for the date of manufacture off of this unit. And I know for a fact that even though I only installed this a couple months ago, I actually bought this over a year ago. So chances are, since I have no way to prove that I've only been running this for a couple months, they probably hear that story all the time. They're going to just go on the assumption that I installed it shortly after I purchased it. And they're going to assume that that's within a certain range of that manufacturing date, so they may void my warranty anyway, so I might not have any choice but to try and get this repaired on my own by either buying a new db110 assembly here, which God knows how much that costs, or maybe I could actually figure out what's wrong with this circuit and repair it. Right, so here's the wiring diagram on the back side of the plate there, and it's a pretty easy to follow diagram, and there's actually, in the troubleshooting section of the installation manual, there's actually an alternate diagram that shows you how you can wire this so that the motor input wires are directly connected to the line input, which would create a situation where the fan just runs constantly as long as the breaker or power is applied to the input. And I'm going to actually do that as a temporary measure so that I can continue to use the booster fan with the dryer and continue to dry my clothes while I'm waiting for the replacement pressure switch to come in. So the other problem I have is I've got to get the manufacturing date off of the unit in order to hopefully get warranty replacement of that pressure switch assembly. Because the cheapest I found that switch for sale is on eBay, $50 with free shipping. On Amazon, it's like $73, and some places it's even more than that. So it's an expensive unit. My other problem is that this box is facing away from me out towards the edge of the house there, where I have like no room because there's a duct right there. So this is going to be interesting. So I don't know if you guys can appreciate how difficult it is to get to this because of the fact that this box, junction box that I need to get to, is facing that way, and I've got no clearance here because of a duct, and then I actually have the roof overhead sloping down over me, so it's very tight. So I can't see into this box, I can only feel. So I've actually got a mirror down here positioned so that I can actually work by looking in the mirror, which is a little tricky, but it's doable. But one of the things that makes it so difficult is, let me actually get a shot of the mirror here, and you can actually see my hand. I'm moving the terminal block that all of these wires terminate to, and what these guys did at Fantech is they mounted this terminal block with a screw inside this box, and you can't get a screwdriver in there normal because there is no room, especially with the wires in there. Even the shortest stubby screwdriver is not going to work, and you can't get one at an angle. It's almost impossible. But what I found is that you can get a screwdriver in through, let's see if right here, you can get a screwdriver in through this hole, which is where the connecting the input line power cable goes in. And I got a Romex connector on here, so I had to unscrew the nut on the inside, move the Romex connector out of the way. Sorry about the shakiness here, I'm trying to, so move, and then I can move this out of the way, and I can sneak a screwdriver in there, get on that screw, unscrew that one screw, then I'll be able to move that terminal block out here where I can actually see it and undo the wires. Okay, so here we go. I got the terminal block out. Now I can clearly see it. So it's pretty easy. This black cable right here with these very thin wires is actually, believe it or not, going to the motor windings. This, let's see, I think these two red wires right here are going maybe to the capacitor. Must be a start capacitor in there or something. Of course, these are my input wires here: white, neutral, black, hot, bare copper wire for ground. And then over on this side, this green wire with the yellow stripe is the ground wire going to the pressure switch. The black wire is the hot wire going to the pressure switch. And the white wire is the neutral wire going to the pressure switch. So basically, your neutral is your return path. So the power is coming in on this hot wire, goes into the pressure switch on this black wire, comes out of the pressure switch on this red wire to this terminal block, which feeds this black wire, which feeds a run winding more than likely, and then also feeds this red wire, which probably goes to the capacitor, and then comes back from the capacitor on this red wire to this brown wire, which probably goes to a start winding. So that's what it looks like before I take it off. So I'm going to have to remove this wire, this green and yellow, this black wire, the white wire, and the red wire, and then I'm going to have to relocate a couple of wires. So here in the manual is the diagram for wiring this for troubleshooting procedures, which essentially you're completely bypassing the pressure switch and you're just having the line go directly to the motor, the fan, which means as soon as the circuit's energized through your, whatever breaker you have this running off of, it's going to run the fan, and it's just going to run constantly, whether the dryer is on or off. There is no pressure. It is not monitoring the dryer's pressure. I apologize for the flickering, but it's this piece of crap, cheapo junk LED. It's literally one LED in the whole array that is intermittent, which is causing this annoying flickering. Alright, so here's what it looks like wired in troubleshoot mode. We've got the neutral is still going to the neutral wire directly on the fan motor. The hot wire now is going into the capacitor, coming back from the capacitor going to the start winding, and also the hot wire is going directly to the black lead on the fan motor. So now when I energize this circuit, the fan should just immediately start running. So the fan motor is fine, which is what I suspected. Okay. I put the cover back on the little junction box and tightened up the strain relief. So now I can, just going to run an extension cord so that I can just plug this into a wall outlet, instead of having to come up here to the attic to turn this thing on every time we run a load of wash between now and the time it takes for the new switch to come in. And oh yeah, I got to get that year of manufacture off of this thing. Hopefully I'll be able to get it with the mirror, and then we'll take this thing down to the workshop and look at it in the better light of the test bench and see if we can't see anything interesting.